Welcome SYVS students. Today we are going to discuss about skill enhancement course vector calculus. Some examples on the topic limits, continuity and differentiation. Example, if r vector is equal to x cos y I vector plus x sin y j vector plus a raised to my k vector. Find dava r vector by dava x, dava r vector by dava y, dava square r vector by dava square, dava square r vector by dava x square. Fourth, dava square r vector by dava y square. Fifth one, dava square r vector by dava x dava y. Solution. Since r vector is equal to x cos y I vector, x sin y j vector plus a raised to my k vector. First, dava r vector by dava x. Differentiate r vector with respect to x is equal to. Here cos y is constant, derivative of x is 1. Cos y I vector. Here sin y is constant, derivative of x is 1. Sin y j vector plus this is constant with respect to x. Here 0 k vector. Is equal to cos y I vector sin y j vector. Second, dava r vector by dava x dava y. Differentiate r vector with respect to y. Here is x is constant. Derivative of cos is minus sin y I vector plus x is constant, derivative of sin y is cos y j vector plus a with respect to y, a is constant, e is to derivative of e is to my is e is to my and derivative of my is m k vector. Third one, dava square r vector by dava x square. Differentiate dava r vector by dava x again with respect to x, we get 0, 0 vector. Because with respect to y, with respect to x, derivative of cos y is 0, derivative of sin y is 0. We get 0. Fourth, differentiate dava r vector by dava y with respect to y. Therefore, dava square r vector by dava y square is equal to, with respect to y, again minus x is constant. Derivative of sin y is cos y. I vector and derivative of cos y is, here x is constant, derivative of cos y is minus sin y j vector plus a m is constant, derivative of e raised to my is e raised to my, and derivative of my is em, here m square into k vector. Fifth, dava square r vector by dava x dava y is equal to, differentiate this with respect to x. Minus sin y is constant, derivative of x is 1, I vector. Here cos y is constant, derivative of x is 1 plus 0 k vector, because am e raised to my is constant with respect to x, is equal to minus sin y I vector plus cos y j vector. Next example, if u vector is equal to x square y z I vector minus 2 x z cube j vector plus x z square k vector and v vector is equal to 2z I vector plus yj vector minus x square k vector. Find dava square dava x dava y of u cross v vector at point 1 0 2. These are the values of x y z. Solution. Let u vector cross v vector is equal to determinant I, j and k. U vector here x square y z minus 2 x z cube, here x z square. V vector 2z y minus x square. This is determinant of U for U vector and cross V vector is equal to I times minus minus plus 2x cube z cube minus x y z square minus j vector this into this minus x raised to 4 yz minus this into this minus 2 xz cube j vector plus k vector x square y square z x square y square z minus 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 plus 4 times x z raised to 4. This is u vector cross v vector. Now differentiate u vector cross v vector with respect to y. Divided by y, u vector cross v vector is equal to I times this is constant with respect to y, derivative is 0 minus x z square is constant, derivative of y is 1 minus j here minus x raised to 4 z is constant with respect to y, derivative of y is 1 minus with respect to y this becomes 0 because it is constant. Plus k vector x square z is constant with respect to y, derivative of y square is 2y plus with respect to y this is constant. Therefore, divided by y u vector cross v vector is equal to minus xz square I vector minus minus plus x raised to 4 j vector plus 2 x square yz k vector. Again differentiate with respect to x. Therefore, dava square dava x dava y of u vector cross v vector is equal to differentiate with respect to x. This equation differentiate with respect to x. Here minus z square is constant, derivative of x is 1 I vector. Here 4 z is constant, therefore derivative of x raised to 4 is 4x cube z j vector plus here 2yz is constant, derivative of x square is twice x, here 4xyz k vector. Now dava square by dava x dava y of u vector cross v vector at point 1, 0, 2 is equal to, here the value of x, 0 is y, 2 is z. Therefore minus z square, that is minus 2 square, that is minus 4i. Plus 4, 1 cube into 2 z vector. Here x, y, z, but here y is 0, therefore this product becomes 0. Is equal to minus 4i plus 8j vector. Next example. If r vector is equal to a by 2 x plus y I vector plus b by 2 x minus y j vector plus xy k vector. Find scalar triple product dava r vector by dava x, dava r vector by dava y, dava square r vector by dava x square. Second, scalar triple product dava r vector by dava x, dava r vector by dava y, dava square r vector by dava x dava y. Solution. Since r vector is equal to a by 2 x plus y I vector plus b by 2 x minus y j vector x y k vector. Differentiate these with respect to x. Dava r vector by dava x is equal to a by 2 is constant, y is constant, derivative of constant is 0, derivative of x is 1, I vector plus b by 2, here minus y is constant, derivative of constant is 0, derivative of x is 1, j vector plus y is constant, derivative of x is 1 into k vector. Again differentiate, now differentiate r vector with respect to y. Dava r vector by dava y. A by 2, x is constant with respect to y, derivative of constant is 0, and derivative of y is 1, I vector. Here b by 2 is constant with respect to y, x is constant, derivative of constant is 0, and derivative of y is 1, here minus 1, j vector plus x k vector. Now differentiate dava r vector by dava x again with respect to x, dava square r vector by dava x square is equal to a upon 2 b upon 2 y are constant with respect to x. Therefore, we get 0. Dava square r vector y, dava x, dava y. Means differentiate this with respect to x. Here a by 2 is constant, derivative 0. b by 2 is constant, derivative 0. Only derivative of x is 1, that is k vector only. Now, first, scalar triple product dava r vector by dava x, dava r vector by dava y, dava square r vector by dava x square is equal to dava r vector by dava x, dava r vector by dava y, but dava square r vector by dava x square is 0. 0 vector. This is the determinant in which the last row is 0. Therefore, the value of scalar triple product becomes 0. Second, dava square r vector y in a scalar triple product, dava r vector by dava x, dava r vector by dava y, dava square r vector by dava x, dava y is equal to determinant I is a k and I is determinant a by 2, b by 2 and y. A by 2 minus b by 2, here x, 0 vector 0 0 for k vector is 1 is equal to a by 2 minus b by 2 into 1 is minus b by 2, and 0 into x is 0, minus 0, minus b by 2, a by 2 into 1 is a by 2, 0 into x is 0, minus 0, plus y, this into this 0, 0 minus 0 is equal to minus ab upon 4 minus ab upon 4 is equal to minus ab twice ab upon 4 is equal to minus ab upon 2. Next example. If u vector is equal to z cube I vector minus x square k vector, v vector is equal to x y z j vector and w vector is equal to 5xy I vector plus 3j j vector. Find delta cube upon delta x, delta y, delta z u vector cross v vector dot w vector. That is scalar triple product. Solution. Let u vector cross v vector dot w vector, that is scalar triple product. Determinant of u vector z cube, j is absent, 0 minus x square. In v vector I and k are absent, therefore j is 2 x y z, coefficient of j is x y z. 5 x y, 5 x y, 3 z 0 is equal to z cube, this into this 0, this into this 0. Here 0, this into this into this 0, minus x square this into this 0, 5 into 2, 10 x square y square z. Is equal to, this becomes 0, this becomes 0, minus 10 x raised to 4 y square z. U vector cross v vector dot w vector. Differentiate this with respect to z. Dabba z, u vector cross v vector dot w vector is equal to minus 10 x raised to 4 y square is constant. Derivative of z is 1. Again differentiate this with respect to y. Dabba square, dabba y, dabba z, u vector cross v vector dot w vector is equal to. With respect to y, here y square minus 10 x square is constant with respect to y. Therefore x raised to 4, y square is 2y, therefore minus 20 x raised to 4 y. Again differentiate this with respect to x. Dabba cube, dabba x, dabba y, dabba z is equal to u vector cross v vector dot w vector is equal to. With respect to x, 4x cube minus 20y is constant, derivative of x raised to 4 is 4x cube minus 80 x cube y. Therefore, dabba cube u vector cross v vector dot w vector upon dava x, dava y, dava z at point no point is there. Okay, we stop here.